Hello everyone and welcome to this video. In this video we want to see that how we can balance this redox equation. We have this equation and we want to balance it. Keep this thing in mind. Balancing a redox equation, you just want to follow some steps and we can get the answer. What's the first step? First step is that you have the equation with you, which is like Fe2 plus MnO4 negative, which is giving you Fe3 plus Mn2 plus. You want to find the oxidation states. Try to find the oxidation states. Using the rules of oxidation state, you can see this is an ion, so what's the oxidation state here? It is +2. For Mn, you want to find, ignore the oxygen for the time being, it will appear later. If you know how to do it, it's like X plus 4, oxidation state of oxygen is -2 equals to what? -1. From here you can see that it's X minus 8 equals to -1, so X equals to 7. So Mn here is how much? 7. Here we can see that Fe is now +3 and Mn is how much? It is +2. Now after finding the oxidation states, we want to see where is oxidation and where is reduction. If you see here Fe from 2 it became 3. It increased, oxidation state increased, so this is oxidation, right? And here it is 7. From 7 here it became +2, so it means it's reduced. Like from 7 it decreased, oxidation state decreased, it means it's reduction, so there is reduction here. Now what we want to do in the next step, we want to write them separately. Let's write separate. We have Fe2 plus, it became Fe3 plus. When it became Fe3 plus, surely it lost an electron because it increased now from 2 to 3, so one loose, we can write it here. And on the contrary, when we have MnO4 negative, it was 7. MnO4 negative, it was 7, so it gained electron and it became Mn2 plus. So it was 7. How many electrons it must gain to become Mn2 plus? Surely it should be 5 electrons. How I can say it is 5? Because you see here it was 7. From 7 it became 2. So what should I minus? It should be -5. It means it has gained 5 electrons. Now the problem is, it is not possible that it is gaining 5 electrons and it's losing 1. It should be equal. Always keep this thing in mind. In this step you want to make sure that electrons lost should be equal to electrons gained. There is no other source. From which source these electrons came, it's only the source from here who lost. But Fe is only losing 1. So we can say clearly from here that it must be 5 Fe's, because 1 Fe is losing 1, so it should be 5 Fe's, so that these electron loss and electron gain can be cancelled. Do you understand? Lost should be gained. We have 5 gain, so it should lose 5. It is not possible it is gaining 5 and it's losing 1 only. It should be equal. So make it equal by multiplying 5. Now we can write the remaining equation. When we write the remaining equation, we have it here 5 Fe2 plus MnO4 minus. It gives me 5 Fe3 plus Mn2 plus. Half of the question is done. Now I want to see something else. We want to balance the charge. Next thing is we want to balance the charge. If you look here, it is 2 multiply 5, so it is 10. And overall the charge is -1. 10 minus 1 is 9. So here on the reactant side it's 9. Now let's check at the product side. It is how much? 3 multiply 5, it becomes 15, and it is how much? 2. So 15 plus 2, it becomes how much? 17. They are not equal. How much this is short? This charge is short of 8. It is 8 short because it is 17, this is 9, so I have to add 8 in it to make it equal. Now keep this thing in mind. When you want to balance the charge, the side which is short, we use H plus to balance the charge, and on the other side, to compensate this H plus, we use water. This is the rule. Now let us write the final equation. I have 5 Fe2 plus MnO4 negative. How much is short? 8. So I write 8H plus, and it gives me 5 Fe3 plus MnO2 plus. Now I have had 8H I have added here. To compensate it 8, I have to use water here. So one water has 2. So how many water molecules I should put? 4H2. 4H2. What we did here is that because the charge was short, so we use H plus. We use here H plus. How much? How much is short? This was 9, this was 17. So to compensate it, we put here this 8H plus. Now to compensate this 8H plus, we have to put here 4 water molecules, because 4 2s are 8, and it gives us the answer. This is our final equation. Now sometimes they can also ask you to find the oxidizing agent and reducing agent. We know oxidizing agents are the one who himself oxidize so other get reduced, and the reducing agents are the one who himself reduces so other can oxidize. In this statement you can see which one is oxidized and which one is reduced. From there you can pick which one is the oxidizing agent and which one is the reducing agent. Let us see. If you see, this Fe is oxidized. Okay, it is oxidized, and this MnO4 was reduced. We discussed in the first step also. He himself oxidized. He oxidized so the other one can reduce. So basically this Fe helped this one to reduce. How he helped? He oxidized so the electron he lost can be gained from the other. So this is your reducing agent. And this one, if you see, you can read like he reduced so it can oxidize. So this one is your oxidizing agent. If you get confused, you can also pick it like the thing which is oxidized will be your reducing agent, and the thing which is reduced will be your oxidizing agent. That is how you can balance redox equations. Thank you so much for your time. I hope you have understood.